Hello everyone, welcome to Platinum Lessons. I am Victor Oludadipo. In this lesson, I'll discuss measurements in physics. We'll jump right into it after the break. When a measurement is made in physics, the result is expressed to show two important parts: the size of the measurement and the yardstick or standard used in making the measurement. As an example, if we measure the length or distance that a car moves from one point A to another point B, a typical result could be 50 meters. 50 here shows the size of the length when measured on the meter scale, that is, 1 meter in 50 places. Measuring the same length in feet, however, will give about 164 feet. That is 1 foot in 164 places. Length, just like other physical quantities, can be measured using different standards or units. So, while the measured quantity is same in size, the figures that would be obtained using different standards or units will be different, as we saw in the previous example where 50 meter is the same as 164 feet. So, a unit of measurement is a clear standard for measuring physical quantities. So far, we have talked about length. There are, however, many physical quantities which we measure in physics. A physical quantity is that property of a material whose size can be measured especially by using a physical device or process. Examples of such are length, time, mass, area, volume, force, density, pressure, and so on. Physical quantities can be classified into two: fundamental and derived quantities. Fundamental or basic quantities are so called because they are primary and cannot be obtained by combining any other quantity. The 7 fundamental quantities are mass, length, time, current, temperature, luminous intensity, and amount of substance. One or more fundamental quantities can be combined in different ways to give a new quantity. The new quantity is called a derived quantity. For example, the speed of a car can be expressed as the length or distance moved by the car divided by the time it takes to cover that length. Thus, speed, which combines two fundamental quantities, length and time, is a derived quantity. We can derive the units of a derived quantity from the units of the parent quantities. In this case, the unit of speed from length and time. Since speed is length divided by time, the unit of speed will be the unit of length divided by that of time. So, we obtain meter over second, which is simply written and pronounced as meter per second. Note that meter per second is a derived unit. Generally, fundamental quantities have fundamental units, while derived quantities have derived units. Take a look at a few other derived quantities and their units. Next, we discuss multiples and submultiples of units. These are important when we try to express very large or extremely small sizes of quantities being measured using a particular unit. For example, the transmission frequency of a radio station is estimated as 95 million hertz. This is a very large number, and it would be more convenient to express the value as a larger version of the hertz. Referring to the table shown, we can instead write the frequency using a multiple of the unit hertz. We write the value to the closest power of 10, that is 95 times 10 raised to power 6. 10 raised to power 6 is referred to as mega. The frequency would thus be 95 megahertz. The next table shows submultiples of units. These are used when we need to express very small values. If a boy measures the thickness of a piece of paper as 0.0001 meter, can you try expressing this value using a suitable submultiple unit? You have 15 seconds. Okay, the wavelength can be expressed more conveniently as 0.1 millimeter. Simply rewrite 0.0001 as 0.1 times 10 raised to power minus 3, with 10 raised to power minus 3 regarded as milli. Be mindful, however, that milli is written as small letter m as against mega in multiples, which is capital M. Now, let us consider the International System of Units, which is for short known as SI units. The system is the internationally accepted standard of measurements. For global uniformity, scientists adopted a single unit for each quantity. This unified set of units is known as the SI units. For example, of the several units for measuring mass, which include the pound, ton, kilogram, gram, oz, and so on, the kilogram was chosen. The table here shows the SI units of the 7 fundamental quantities and a few derived quantities.
That's about it in this video. Hope you enjoyed it. Please give a thumbs up if you find this video very useful and leave a comment or request in the description below. Thank you.